Hi, in this video I'm going to show you how you can calibrate a system that is using two laser line scanners and a transport system, for example a conveyor belt. To show you the data that is being used in such a situation, I'm loading a script which is being installed together with the samples when you install the SDK. And I'm just running this script once so that we see everything that is being used in this situation. So here we see we have two point clouds from the original scanner, and we have the result after calibration. And I'm going to show you in this video how you get from this to this. I'm just doing it with one of the 2 point clouds, and to have a nicer visualization I'm computing the surface normals of this point cloud. Now it's being visualized with a shaded view. So when we look at these points directly after scanning, we see that the data is sheared. So there's an error, and this error is coming from the transport. So the scanner is generating the point clouds in XYZ under the assumption that the transport direction is along the Y coordinate. But in the real world, the orientation of the scanner is never 100% aligned with the coordinate system. So we need to calibrate the real transport in X, Y, and Z that is happening. And this will get rid of this shearing effects. And then second, we have to find the global orientation of the scanner and apply it so that the center of these spheres is in a defined target coordinate system. So I'm going to load this target coordinates. So these are the 4 center points of the spheres in the target coordinate system. And to compute the calibration, we need to extract the points on the spheres from the data. So in this demo video, I'm just going to use the 3D view, and I'm going to select all those points that are visible in the current view. Now these points are the points on the spheres. We select them and the target coordinate positions, and then we can compute the calibration. So the radius of the spheres was 19.05 millimeters, and the transport direction was the Y direction. So the result from this process is a calibration of type linear transport calibration, and we can apply this calibration to the original scan data. Point cloud calibration, apply. So now what we see is the calibrated and corrected point cloud, computing the normals. So here we see that there is no shearing anymore. Everything is perpendicular as it should be, and we see that the position of the spheres is where it should be. So when we do this with a second scanner, then we get this result, and after that we can inspect the scan data. So in a real world application, what you usually do is that after installing your system, you compute the calibration of the 2 scanners, you save it to disk, and when you are running the machine, you load the calibration from file, and for each scan data that you get from your scanner, you apply it to this point cloud, and then you can inspect according to your inspection program for the objects that you want to scan.